Alrighty, so now we're going to be looking at the very last topic for this unit, simultaneous equations. So to kick us off, I want you to consider this statement here. So we've got two numbers that add up to 10. What different possibilities could we have for those two numbers? Okay, so let's have a look. So two numbers that add to 10, lots of different possibilities. We could have some integers such as 1 and 10. Sorry, 1 and 9, both of them add to 10. 2 and 8, we got 3 and 7. We could have 4 and 6, 5 and 5, and so on. We could also have some integers as well, some fractions. So I could say, let's go 3 and a half and 6 and a half. That fits. We could have 3 and 2/3, and then 6 and a third. What else could we have? We could have some decimal values, so we could have 5.62 and then 4.38. Sorry, yeah, that's about it. Okay, so almost infinite possibilities, especially if we can include decimals and fractions. Okay. Now, we could possibly rewrite this using algebra. We could say that x plus y is equal to 10, okay? Where x and y are both numbers that we don't know yet. Okay? I'm going to add an extra condition now. So now the difference between those two same numbers is 2. What could those two numbers actually be? Okay, so let's list down the possibilities of two numbers where the difference is 2. Okay, so we could have 8 and 6. We could have 4 and 2. We could have, I don't know, we could have 12 and 10. We could have, let's try 14 and 12. Okay, or we could have 4 and 6, okay? Now again, we could write this algebraically by x minus y, so that's what we mean by the difference is equal to 2. Now, given these two conditions, what must those two numbers be? Well, we have a look at our different possibilities up here. There are only one set each that actually match this condition. 4 and 6. Those are the only two numbers which actually fit this. Now what we've just done there is solved simultaneous equations. Simultaneous means at the same time. What we meant by at the same times is both of these statements were true. Okay, they were conditions that constrained what numbers they could be, and these equations are referred to as being simultaneous. They represent those conditions. And when we solved them, this is what we did when we listed out the possibilities, we were finding, well, what numbers satisfies both of these conditions? And in this case, we found it was 6 and 4. That's what we mean by solving those simultaneous equations. Okay, now if we wanted to have a look at these graphically, let's plot them here. Okay, so we found out what those equations were. One of them was, x plus y is equal to 10. And there's our graph that represents that. And we can have a look and see the different possibilities we have for that. Those two numbers could have been 0 and 10. We didn't really specify that it had to be positive. They could also have been -1 and -1 and 11, because -1 plus 11 is equal to 10. We only really considered the positive ones though. What else did we had? We had that number there, we had 2 and 8, and then we can see all these decimals along here. They represent the same thing, all add to 10. This one too, 4 and 6, and then we had 6 and 4, 8 and 2, and then also 10 and 0. Alright, let's write the next line. Hide this one first. X minus y is equal to 2. Okay? So same idea, we could have a look at those numbers that we had a guess at. We had 3 and 1, also had 4 and 2, 6 and 4, 5 and 3, and we could go anywhere along this line will be true, okay? Now let's put both of those at the same time. So we came up with those two numbers must be 6 and 4, which is right there, and that's where the graphs meet. So wherever the graphs cross, whatever that point is, means that those numbers must satisfy both of those lines, or in this case, both of the conditions that we have. And this is also what it means to solve the equations simultaneously, except we're using a graphical form here, which is perfectly fine. So that's introduced. So that's one part of simultaneous equation. Let's have a look at another one. The perimeter is 10, the area is 6. What could those dimensions be? So again, we could write equations which represent both of these. The area one's probably the straightforward one. If we x and y are our length and our width, let's write that as an equation for the area. We know that we multiply the length and the width, so that's x times y is equal to 6, which we could just write as xy equals 6. So what different possibilities could we have? We could have 1 and 6. We could also have 6 and 1. We could have 3 and 2, and then 2 and 3. What else could we have? We could have 12 and a half, for example, because 12 times a half is 6. Could also have 18 and a third. So lots of different ones, okay? So they don't just have to be integers like this or whole numbers, they can also be fractions. Now let's think about the perimeter. So the perimeter is when we add up the lengths of all the sides. So we've got x plus y, and that is all equal to 10. Now we just got two x's here and we've got two y's, so we can simplify that, collect those like terms. Let's think about what different numbers could satisfy this, okay? So we could have x being 1, and 2 lots of 1 is 2. And then that means y must be 4, because 2 lots of 4 is 8. So we could have 1 and 8. So 1 and 4. What else could we have? We could have a half. Could we do a half? Yeah, we could do a half. So 2 lots of a half is 1. And then we're left with 9. And half of 9 is 4 and a half. So we've got half there and 4 and a half. So that works too. Let's try 2. So 2 lots of 2 is 4. We're left with 6. And 2 lots of 3 is 6. So that must be that one there. And yeah, we'll go with that one for now. Okay? So again, lots of different possibilities. There could be many different ways that could happen too. And just like the last one, we need to find, okay, what two numbers fit this condition exactly? Well, we have a look here. The 2 and the 3 and the 2 and 3 there are the only ones, at least that we thought of, that could match those conditions. Okay? There could be other options as well. Well, let's check that by drawing the graph of both of them. Okay, so let's get rid of these. So our first equation was our area. So x times y equals 6, which is this funky little graph here. It's not a straight line. That's okay. And then we knew that the perimeter, so 2 lots of the length plus 2 lots of the width, that was equal to 10. And now we've got here. In this case, if we zoom in here, it actually touches the graph at 2 points here. So there are 2 different numbers that could fit this. All right, in this case, we got that number there, 2 and 3, and this one, 3 and 2, which is exactly what we found here. Okay, so again, it doesn't have to look like a straight line, but we're mostly going to be dealing with straight lines anyway. In fact, it goes all the way there, and that's because when you multiply 2 negative numbers together, you get positive, so that works there. But these are the 2 we're mostly interested in here, because that's where the 2 graphs intersect. So that's basically it. That's what simultaneous equations are. They're numbers that satisfy certain conditions or equations. So these are our 2 conditions here, which are represented by these 2 equations. when we list the different possibilities that satisfy those equations, we look for those numbers which satisfy both of them, and that's our solution to that. And just as we saw here as well. And we used graphs to graph them and do the same thing, except it's much quicker. And that's what we're going to be doing in the rest of this topic. You can also solve them algebraically.